All right, so these are some of the problems that we didn't get to today. So we're going to start here. Look at this problem. We have a negative 4f is greater than equal to a positive 20. Excuse me. So this looks just like some of the equations that we've been working, but the only difference is it has an inequality sign in between it instead of an equal sign, right? So the same thing you would do if you saw this problem with an equal sign, we're going to do with the inequality sign. So we're just going to do the opposite of what we see. We know that whenever a number is directly next to a variable that we're multiplying. So here we're going to do the opposite, which means we're going to divide. So the same thing you would do if we were doing a regular equation. We're going to divide. So we're going to divide negative 4 on both sides. And we know that these cancel. So now we're left with f. And from the video you just watched, we know that we have to flip the sign. Okay? And negative 5. All right? So we all know that whenever you have a line underneath the inequality sign, that we have to draw a dot. Not an open circle, but a dot. Okay? So we're going to try 2 test points. A test point will tell us which way we need to shade. So if we are left with f is less than negative 5, we're going to try a test point on both sides. So we're going to choose negative 8 on the left side and negative 2 on the right side. So if we have if we have f is less than equal to negative 5, we're going to try negative 8 first. So negative 8 for f. So if we use negative 8 here, let's read it as negative 8 is less than or equal to negative 5. Is negative 8 less than negative 5? Yes. All right, let's look at negative 2. Is negative 2 less than negative 5? No, it's not. So that lets us know that we're shading in this direction, right? Excuse my line. I don't have my pen. Okay. So let's look at the next problem. We have negative 77 is less than equal to negative 7. So we're going to do the same thing that we did on the next problem. The only difference here is this number is positive, right? So let's make sure that we pay attention to the signs, okay? So let's do a few steps. So we know that we have to, in order to get rid of this 7 and get this n on the side by itself, we have to divide both sides by 7. So when we do that on this side, we're left with an n. And do we have to flip our inequality sign? No. No, we don't, because this 7 is a positive 7. So the only time you'd flip your inequality sign is if the number that you're multiplying or dividing both sides by, which is this 7, is negative. And if in this case, since it's positive, we keep our sign and we don't flip it. So be very careful with that. Excuse me, I didn't mean to write this 7. Okay, so once we divide this side by 7, we're left with a negative 11, right? Because negative 77 divided by 7 gives us negative 11. All right, so now that we have what we need, now it looks like a normal problem that we can just go ahead and graph, right? So we want to know if negative 11 is less than n. So since we have, now we need to know whether if we need an open circle or a dot. We know that it's going to be a dot because we have a line underneath this inequality sign, right? Because we have a line. So we know that we need a dot at -11. All right, so we're going to use two test points. I'm going to use -15 and -8. So we're testing to see if -11 is less than -15. Is -11 less than -15? No. It's not, because -15 is here and -11 is here. And we have to travel to the right, which means this number is getting larger to get to -11. So we can't use -15 because it doesn't work. It's not -11 is less than, -11 is not less than -15, excuse me. All right, so let's look at -8. Is -11 less than -8? Yes. All right. So we're going to shade in this direction. Okay. All right. So let's try another problem. Here we have y over 7 is greater than equal to -6. All right. So here we're dividing. This is division. Y over 7 indicates division. So what we're going to do, see, I don't want this thick. What we're going to do is the opposite. And we know that the opposite of division is multiplication, right? So we have, and we know we have to flip it. 7 over 1. We learned that last week, right? So we know that these cancel, and we know that there's an understood 1 in front of this y. So 7 times 1 is 7, and 1 times 7 is 7. 7 over 7 gives us 1 over 1, and 1 over 1 is just 1. So we're left with y on this side. Okay? And since we multiply by a positive 7, we don't have to flip our sign. So let's come on this side, and whatever you do to one side, we know we must do to the other. So if we multiply this side over here, excuse me, by 7 over 1, we must multiply this side also by 7 over 1. So a -6 times 7 gives us a -42. Okay? And we know that this is over 1, and 1 times 1 is 1, and we don't need that bottom number. All we need is -42. So our new point is -42. So I'm going to draw, do I need a dot or an open circle? I have a line here, right? Okay, so we know we need a dot. All right, so I'm going to change the color to draw our line. But first, we're going to try 2 test points. So I'm just going to choose -46 and -39. Okay, so let's look at this. What we want to know is if y is greater than -42. Is y greater than -42? So if we use -46 for y, is -46 greater than -42? No, it's not, because -46 is here and -42 is here, and we have to travel in this direction to get to it. So -46 is not greater than -42. So let's look at -39. Is -39 greater than -42? Yes. Yes, -39 is indeed greater than -42. So let's draw our line here, in the direction that we need it to go in. All right, let's try another problem. And remember that you can always pause throughout this video if you feel like I'm moving a little fast. Just pause. I have to talk pretty quickly because I'm timed. All right, so let's look at this problem. And just like we would do in a regular one-step equation, we're going to do the same thing in this inequality. Look at it. Are we multiplying or dividing anything? No. We're adding or subtracting. So here, in order to get rid of this -3 so that k can be the only thing on the side of this inequality by itself, we must add 3 to both sides. Since this is a -3, we're going to do the opposite. We're going to add 3 to both sides, okay? So these 3's cancel, and we're left with 0. And when you're adding and subtracting, the sign never flips, okay? And these also cancel. So all we're left with on this side is k, right? Okay, so do we have a line underneath this inequality sign? No. So we're going to draw an open circle at 0. So I'm going to change my color real fast. So what we're trying to figure out, I'm going to use 2 test points, is if 0 is greater than k, what can k be? If 0 is greater than k. So is 0 greater than -2? Yes, 0 is greater than -2. Is 0 greater than 3? No, 0 is not greater than 3. So we know it can't be any numbers on this side because all of these numbers are greater than 0. And we need numbers that are less than 0 because it asks us to find numbers that 0 is greater than. So 0 is greater than all of these numbers. So we have to draw on this side of the graph, okay? So let's look at the next problem. Let's look at this one. Uh-oh, wrong button. So this one is kind of just like our last one. And I'm going to change this. All right, so let's look at this one. Okay. Hopefully my sound is working right now. Okay. So has anybody figured out what we want to do first? Yes, we're going to add 4 to both sides. Because I know you said it. So we're going to add 4 to both sides. And when we add 4 to this side, we know that these cancel. And all we're left with on this side of the inequality is n. And remember, we keep our sign because we're not multiplying or dividing. And a -13 plus 4 gives us a -9. So we're going to draw a line. Be real careful with this graph because it's going by increments of 2. But it still gives us the point of where this -9 falls. So do we need a dot or do we need an open circle? A dot, right, because we have a line underneath this inequality sign. All right, so we're at -9, and we're going to use -12 and -6. We need to know if -9 is greater than n. So if we use -12 for n, is -9 greater than -12? Yes. All right. So we're going to use -6 now for n. Is -9 greater than -6? Is -9 greater than